Get it started. So yeah, you all know me, myself Hari. So once again, good evening, all of you. So we are from High Tech Institution, you know well. Every weekend, right? We used to conduct some real project discussion. So many of them, gave me the feedback. This is really helpful for them when they face interview. That is the reason we are started continuing for every weekend. This is totally attending for the free of cost as a basis of knowledge sharing platform, right? Whatever the knowledge I know, I used to share with the people. Okay. So in that, right, we are planning to discuss about 25 projects. So far, we are able to complete up to 16 projects. Today, what we're going to talk, that is 17th project, something, host a scalable web application using AWS EKS with external load balancer. Okay. This is the target. This is the expectation. We are going to deploy the application using Kubernetes. Yes, of course. So we are from High Tech Institution. And if you guys having any doubt related to this project, feel free to stop me at any point. Okay. And apart from that, right, you have any doubts or question about your career or anything generic, the end of the session we'll have a parking lot. You can ask your question. Okay. The people who are attending live, also this video will be uploaded in the YouTube channel as well. Any people watching this video in YouTube, feel free to go to the description. You will get the WhatsApp group link. Click on the link. You'll be joined into the WhatsApp group. So you can also start attend this session for live. Okay, good. Let me get started with the project 17. Host a scalable web application using a AWS EKS with external load balancer. So the thing is, the project title is, we are going to have a scalable e-commerce web application on AWS. In AWS, right, we have a service available called EKS, Elastic Kubernetes Service. Straight away, if you take Azure, we have a service called AKS, Azure Kubernetes Service. Okay. So the main intent, people are started using Kubernetes. Maybe if you observe last 2-3 years, right, Kubernetes has lots of growth actually. Suddenly, there are many people are started using Kubernetes because cloud service provider is one of the reason. Okay, irrespective of AWS or Azure, whatever it may be. If you take AWS, they have a service called EKS, Elastic Kubernetes Service. If you take Azure, they have a service called AKS, Azure Kubernetes Service. Okay, irrespective of any cloud service provider, along with the cloud, Kubernetes also getting wider audience and it became peak. Okay. So in that requirement only, we would able to, see the specific, the specific project we are going to deploy it on AWS EKS. The use cases, you are deploying a e-commerce web application. Okay. Front end, they have developed in React, backend and developed in Node.js with MongoDB, a database on AWS EKS. You want front-end service to be accessible over the internet using Elastic Load Balancer. Okay. So whatever the front-end application, right, we have deployed and developed, that has been exposed through, internet. That is the goal. If you go to the architecture overview, we have a user using the internet, right? They will hit my load balancer. Okay. This load balancer is supposed to forward the request to backend parts. Okay. Before understanding the pod, Kubernetes, all those things, right? We have one prerequisite video, which is something will give you the knowledge about what is Docker, what is Kubernetes, what is hypervisor. That data you'll come to know. Let me start, show those information. After watching that, right, you will be able to understand how things are works. Okay. And what is the difference between Docker and Kubernetes? What does mean by pod? All those information, right? You will be able to see. Open my browser. I'll quickly take you into online paint tool. Okay. If you come over here, first thing, before understanding the interviews and things and stuff, you should know one theory, first of all, okay, which is hypervisor. And second thing, you should know what is the architecture of Docker. And third one, you should know what is Kubernetes and how it is different from the architecture level. Okay, that is very important thing to understand. Okay, quickly I'll tell you the concept behind, so everyone can easily connect. We all know when we take a hypervisor, right, we'll be having a hardware like that. Okay. On top of the hardware, we'll be having the either operating system, or you will directly install the hypervisor application. On top of it, right, you will be having a number of virtual machines like this, multiple virtual machines like that. So what are the layers? This is your hardware. Hardware means what? Your CPU, memory, something like that. Okay, this is your hardware. On top of it, right, you will be installing your hypervisor application. Hypervisor means whom? VMware, ESXi, Hyper-V, those applications. Okay, VMware, ESXi, Hyper-V, those applications. These are your VMs. Okay, what is the advantage? So if the hypervisor is not there, right, there is no concept of virtualization. If the hypervisor is not there, if you go any environment, if you take 5-6 years ago, if you go any data center, there will be a physical server, right? On top of that physical server, we'll be installing our OS, we'll deploy our application. But today it's not like that. Okay, once the hypervisor has been introduced, we will be having a hardware. On top of it, we will have a hypervisor. This hypervisor will help us to create a multiple virtual machine from the single hardware. Multiple virtual machine from the single hardware. Here you can host your application 1. Here you can host your application 2. Here you can host application 3. So hypervisor helping you to divide your hardware with, virtually, and making sure to create multiple VMs. And this will lead you into deploying multiple applications. Literally cost saving. Okay. So why then? After the hypervisor, there's the next generation. There's something called Docker. So when you take a Docker, right, you will be having a hardware similar like this. Okay, you'll be having a hardware similar like that. On top of the hardware, right, you will be having something called operating system. There's something called operating system. On top of the operating system, right, we have something called Docker engine. We have something called Docker engine. How your hypervisor helping you to create a VM? In the hypervisor, in the Docker, this Docker helping us to create a multiple containers, guys. The container 1, 2, 3, 4, 5, 6, like multiple container, right? Which is allowing us to create. Okay, so hypervisor allowing us to create VMs, Docker allowing us to create a container. The reason why people are migrated from hypervisor to Docker, what is the reason behind? So when you ask me like that, right? Okay, when you ask me like that, your hypervisor is very expensive. Okay, the VMware license if you go, or a Hyper-V license if you go, that's very, very expensive. And the management server, right, to managing, VMware, vCenter or hypervisor virtual manager, thus that application itself will cost you a huge hardware consumption. Okay, due to cost saving and hardware saving, right, VR came into the Docker. When you come to Docker, right, it's purely open source. We don't want to worry about, buying a license and things and stuff. It's purely a open source one. And this is very lightweight and size, comparatively same hardware only we are using over here and here. See, we can host only 3 VMs here. In that case, we can host double the number of containers. We will able to host multiple application on top of containers, guys. Okay, this is what all about. The difference between hypervisor and container, and where the Kubernetes comes. When you take a Kubernetes, right? So here there is no proper high availability in hypervisor and Docker, especially into Docker, there is no proper high availability. That is the reason we got a Kubernetes. Let me compare the architecture of Kubernetes. When you come to the architecture of Kubernetes, we have a concept called clustering based mechanism. Hope most of you are aware about what is the concept of clustering, right? Okay, Kubernetes cluster. What does mean by cluster? You will have a multiple hardware will be there, guys. This is a node 1. This is a node 2. I mean hardware 2. This is a node 3. This is something called hardware 3. Like that, you will have a multiple nodes will be there. Multiple servers hardware will be there. Okay, on top of these, on top of this node, right, you will have a layer, something like this. Okay, you will be having an operating system like that. Okay, each and every node has operating system. Okay, like this. You'll have a operating system. So this is your OS, and this is your OS. So each and every node in your cluster will have a OS. Okay. On top of the OS, right? Again, you will have a Docker. On top of it, you will have a, what is that? Kubernetes component, something like this. Kubernetes On top of it, right, you will be creating a multiple parts like that. These are something called as a parts. Part 1, part 2, part 3, part 4, part 5, part 6, part 7, part 8, part 9. Like we'll be creating a number of parts we can host our application. So this is how it differs. So Kubernetes is the biggest advantage since it's working in the principle of cluster-based mechanism. Even though if something happened to one particular, even though if something happened to one of my node, if looks like this is down, no need to bother. Still, we have a couple more nodes are part of my cluster. Still, we will be able to access our environment and things and stuff. Okay, so the cluster deploying Kubernetes cluster, we have various options. Are there auto scaling options and all possible? I'll explain about it. Okay, this is the difference. This is the architecture of all these three components. So, any one of you having any doubt in this architecture? Because before we get understand the project 17, you guys should be knowing about the Kubernetes architecture, like node 1, node 2, node 3, like that. We have various operating system. We have a Kubernetes component behind parts. What is meant by parts? These terms are very much important. Any of you having any questions or any doubt in the basic terminology?
No, sir.
Okay.
So here the Docker is same as the Docker engine from like what we're seeing in Docker, right? On the Kubernetes side.
Yeah. Basically, what happened in Docker, we are creating containers. In Kubernetes, we are creating a pod. When you go deep dive into the pod, pod is also something abstraction layer of container only. Inside the pod, you will see the containers. Those containers
Oh,
are being provisioned with the help of Docker only. So
got
in
it.
the Kubernetes setup, if we go in the node 1, node 2, node 3 concepts, along with the operating system, we need to install Docker also one of the prerequisites actually to set up a Kubernetes. So one of the layer, it will be there as one of the layer. Same package only. Whatever the package we are installing in the Docker architecture, same package, same tool only you will install for the Kubernetes also, but you will install it in all the nodes. Node 1, node 2, node 3, every node you will install the Docker package.
And it will be the only one for all the nodes, n number of nodes. How many? It could be like 1, 2, and whatever it is. Just
Yeah.
only one Docker for everybody.
No. You need to install for all the individual nodes. Docker is a prerequisite for every individual node should own the Docker package.
Okay. Got it.
Yep.
Thanks, Sari.
Yep. Any other questions to anyone? Okay, cool. So if you all good, right? Probably I'll start share my document again. So yes. So
Hari, there is a question how Docker related to Kubernetes in the chat. I don't know if you have read that.
how Docker is related to Kubernetes? Yeah, Kubernetes is the open source tool which has been introduced by Google Cloud. So Kubernetes need any one container runtime, any one tool which supports container, which support creation of containers. So predominantly we are using Docker across all over the place. So I mentioned Docker here, but Kubernetes have a functionality or technical capability to support uh, any container runtime tool. Similar like Docker, we have a competitive tool available, RKT, Rocket runtime, KMS something like. So these many container runtime tools are there. Kubernetes can support anything. Okay. Kubernetes is a container orchestration tool, which has self-healing capacity and which has more high availability and all. Very quicker. Docker does not. Okay. That is how Docker is differ from the Kubernetes. Okay.
So basically, Docker Kubernetes is like Docker plus the Kubernetes additional functionalities like orchestration and all those things.
Yep.
Right?
Yeah. So I opened Killer Coda. The people who ever attended my last project, right? They might understand what is Killer Coda. The people who knew to Killer Coda, this is something the place will give you the free Kubernetes cluster for you. Okay. we got the Kubernetes cluster. Same cluster, right? You can create it in AWS or you can even create it in Azure, but you need to pay for it. But yeah, in Killer Coda, it's free of cost. He'll be giving you a free cluster for 60 minutes. If you wanted to extend for 4 hours, you need to become member. I don't want to become member. I'll complete this task in few seconds, a few minutes. So yeah, good. kubectl, get nodes. So here you can see how many number of nodes are part of your cluster. At present, you have 2 nodes. So whatever the pod and deployment we creates, right? We'll create it using this specific 2 nodes only. Okay. Here the expectation is you are deploying a e-commerce web application. Okay, on AWS EKS. Your front-end service should be accessible over the internet using the NLB. Okay, that's fine. If you go to my front-end application, right, what will happen? I need to create a something called deployment. Okay, like this actually. People will be hitting your internet, your application will be deployed. Okay, EKS, backend your applications will be there. Okay. For that, what I need to do in Kubernetes, right, there is a component called deployment. So this deployment will hold my front-end part. I mean, whatever the front-end application, right, those part will be pointed here. Later, what I will do, I need to create a Kubernetes services actually. Okay, Kubernetes load balancer services. Here, our AWS EKS, ELB coming to the picture, load balancer. Okay, this is the hierarchy, by the way. First, we need to create a deployment, then probably we need to create a Kubernetes load balancer service. Okay. So this is the action plan. If you scroll down, right, what are the components involved? Deployment, I told you, right? Deployment front end, deployment back end. I cannot show all the deployments. I'll show one deployment. You guys can follow the remaining things. Okay. Services for backend, services for front end. I'll create one services. You can follow the remaining. Okay. Real-time use cases. User access your web application using public DNS or IP, which means your load balancer, when you are creating, right, you will get the public IP. The load balancer service type we need to use. Traffic router to the front end part inside of your EKS. Okay. Literally, the arc diagram is the deployment with the parts. Okay. This is something your deployment. This will be attached to not able to make proper circle, so I will go with this oval shape. Here you'll get the Kubernetes services. Here you'll find the load balance. Okay, here you'll get the AWS load balancer. Okay. When people are trying to hit the load balancer, here you will get the DNS IP, or when you are creating load balancer, right, either in AWS or Azure, you'll get the either public DNS or IP address, public IP address. With this only, people from the internet, right? They will hit. People from internet, they will hit. This should be your internet. Okay, this should be your public internet. People all over in the world, right? They will be able to hit this public load balancer only. So from this, it will forward to the Kubernetes service. From here, your request will go to pod 1 and pod 2. Here, what exactly your front-end applications are hosted. Here, where exactly your front-end applications are hosted. Got it? So this is architecture. This is what we are going to implement it in the console. Okay. So if you check kubectl, you won't be having any resources. So we need to create the new one. Okay. For creating the deployment, right? We have a YAML file for that. Let me open that. Yeah. Here you can see. So these are all the YAML files we need to use for creating a deployment and creating a service in the Kubernetes actually. Okay. Yes, of course. Understanding this YAML file is a bit difficult initial phase, especially who all new to this particular, Kubernetes. It might difficult for them, but I can tell people, Ubayd, Naveen, and Vijay. Few people can understand because they already Atish. Few people can understand because they know the Kubernetes already. They have studied under me, so they can understand probably. Others, right? Try to understand. Next week I have one more use case where I'll plan to explain the YAML files in detail. Okay. For now, you guys have to understand there is something called deployment. This will create a parts actually. Okay. If you want to confirm, copy this. Go to the Kubernetes cluster, create one file, YAM. I'll paste the content. Let me save the file. In front of you only, I executed kubectl get deployment. It was 0 initially. Now I'll apply kubectl. Okay, when I apply this file, I could see deployment got created. You can even validate this. Okay, you can see deployment got created. The pod got created. Inside the pod, right, you should be able to see the application, front-end application you need to load. Okay. Inside the pod, you need to load your application. How can you load? Kubectl get pod if you give. This is your pod. What you need to do? Kubectl exec -it name of the pod /bin/bash. This is the command, right, to get inside of your pod. This is the command to log inside of your pod. Okay, whatever the pod you created, right, you can go inside. Right now you are inside of the pod. You can go to the path called cd. One sec, I forgot the path. What is the default application path in Nginx image? Okay, /user nginx.html. Okay, I need to go to this path inside of your pod. Like you can see here, 550x.html file, index.html file is available. In this place, right, you need to replace with your front-end application. You need to replace your file with your front-end application actually. Okay, front-end React file has to be replaced with this particular file. Okay, this is the path. I'll even ping you this path in the chat if you guys are trying out. Yeah, make use of this particular. Okay, you need to go to that path. So you need to deploy your application. So now I'll give exit. I'll come out from this pod. So once your application is deployed, right? Once your application is deployed, then probably we need to create a service actually. In Kubernetes, there is a component available called service. Okay. Let me open a document. Okay. The problem is in my system, very difficult to find the documents actually. Yeah, I think this is the document. Yeah. Okay, in Kubernetes, what will happen? This is your cluster. This is your pod. To expose your application to outside world, right? You must need a services. To expose the application to outside world, you must need the services actually. So services is very important in Kubernetes. Without the services, right, you cannot expose your application to outside world. So in Kubernetes, right, we have three different types of services available. One is cluster IP, second one is node port, third one is load balancer. Cluster IP is the default service type in Kubernetes. But using this, right, you can expose the application within your local area network only. Okay, you cannot expose to internet. Within local network, you would able to expose it. Node port and load balancer, you can see it in blue color. Both are helpful when you are exposing your application to outside world through internet. Load balancer play a crucial role because the load balancer service available only with the Kubernetes cluster when you are created in the cloud-based environment. Either your cluster is in AWS or your cluster is in Azure. At the time only you can create this load balancer. So when you these three types available, when you go to the YAML configuration, right? Here you can see I'm going to create a service. How I create a deployment through this YAML, I'm going to create a service. Here you can see selector as app nginx. Here I gave selector as app nginx. Same thing I have even given over here also. So this service is going to create with the load balancer type out of three types, right? Cluster IP, node port, load balancer. I'm going to create a load balancer based service only. It's going to select this deployment. Okay. Copy this. Go to your cluster. If we give kubectl get a service, you can see cluster IP is available. Okay. Only one service by default will be available whenever you create a new cluster, right? This will be there by default. But you need to create a new services actually. kubectl apply -f. Okay, service got created. When I checked the last time, one default service available, right? But now if I check, we should be able to see Nginx service got created. This is what we created. If you wanted to confirm, you can confirm it over here. Service name should be Nginx service. The Nginx service got created. Load balancer, this is a cluster IP. Here you can see pending IP. Here only one IP or DNS thing will be generated. But in killer coda, it won't generate it. But in actual production scenario, right? Your cluster will be there in either AKS or EKS, Azure Kubernetes Service or Elastic Kubernetes Service. At the time, you will able to see the output over here. Okay. So using this, right, you will be able to access your application now. Using this, you will be able to access your application now. How the packet will transfer? I told you, this is currently showing, which is showing as a pending, right? This will be created with some DNS IP or URL in few seconds. So using that, right, people will be accessing. So it will forward the request to Kubernetes service. The Kubernetes service already we pointed the selected the app Nginx using the selector. So the request will forward to the pod 1 and pod. This is how your front-end application will be accessed by the people over the internet. Got it? Any doubt or any questions in the application?
No.
Very good. If people who knew, if they have any confusion how I created this deployment and all, here I'll write the comment probably in the Courier new font. kubectl create Okay, this is the command, whichever the command I written in the blue color, right? So this is the command to create a deployment. This is a command to create a service. Once you create, you will get the automatically load balancer is created in the AWS side or Azure side. You will get the public IP. Using that public IP, if you load it, your application will be performed. And the chat, I have already shared the command. Once the pod has created, right, you can go inside of the pod actually. kubectl get pod. Bin bash. Okay, you can go there and the CD, the chat I paste that path. You need to collect the source code from the developer and you need to paste it over here. Okay. Application source code. Okay. Understood. This is the command, guys. So you'll get the IP address. Anyone has any questions? Any doubts?
Hello.
Yeah.
Yes, sir. How can I just map the public DNS in load balancer? How can I map the DNS?
When
Here.
your load balancer get created, right, it will provide you the public DNS IP. Okay.
Okay.
If you wanted to map in AWS, we have a service available. You need to
Route
extend your
53.
automation. Yeah, Route 53. Using ACM service, you can buy the SSL certificate. In Route 53, you can point it to your domain name.
Okay. Sir, I have another question.
Yep.
That is here you are just showing that it's load balancer, but in production level, can I use load balancer or ingress? Because in load balancer there is I think $32 for per load balancer. In organization there are multiple of application, so that would be good for load balancer or ingress.
Very good question. Appreciating your question. Yes, of course. In your cluster, you are going to have a many number of application going to deploy means in us how you deployed Kubernetes service. Similarly, you need to create a ingress controller. Okay, this ingress controller will help you to set up a multiple ingress rule. Okay, each application. So this is one application you want to deploy in your cluster, but there is in the production scenario, we may get the multiple application has to be deployed in the same cluster and we need to expose it to the outside world. That time probably you can prefer to go with AWS load balancer controller. Then you can plan for a ingress rules. That way it will be cost saving and it will be easy for you to manage for bigger network.
Okay, sir. Okay.
Okay. So yeah. So this is the command and all those things. The architecture. So using that, the load balancer URL, we'll be able to access it. Okay, the same YAML file only I have shown in the code editor. Okay. Load balancer type service integrated ELB automatically. I mean, here we have specified load balancer, right? So it is integrated automatically. Used in the production, make application internet is facing. Okay. So we'll use this load balancer for the internet facing application. Okay. Ideally, when you don't want to manage the ingress controller initially. Since it's one-time application, as I mentioned, you don't want to manage the ingress controller initially. If you are going with the multiple, you can move later to ALB, ingress controller. Okay. It's part of my project. Narayan has asked the same question. That's what really I appreciated his question and input. Well done, well made of question and good doubt, Narayan. Okay. So optional
Thank you, sir.
enhancement, what I mentioned, Narayan and team. Yeah, you can add the SSL certificate in AWS. We have service called ACM. You can point ingress and ALB to your ACL, so you can get a certificate. There is an advanced concept available in Kubernetes called horizontal pod autoscaler. Instead of MongoDB, you can prefer to go with Amazon RDS. You can enable the CloudWatch log or other monitoring tool like Prometheus or Grafana for the monitoring. These are optional enhancement. If you are going for any interview, right? If people are asking about your environment, hey, can you please explain about your application architecture? All those things you can explain. Okay. We are all going for the interview. There is a question from the interview. Hey, can you please tell about your application architecture? Or hey, we have one requirement. We need to come up with the architecture. My client has some application to be deployed in the Kubernetes. How good and how secure and how best optimized way you can set up the infrastructure. So this is a question. You can answer them. Yes. In AWS or Azure, we have a AKS or EKS services available. Depends on customer's requirement. We can go with any one cloud. There we need to create a deployment. There we need to create a services. If more application is going to deploy, we need to create a ingress controller. We'll create an ingress rule. Once we purchase the domain name, right? In AWS, we have a service called ACM, Amazon Certificate Manager. There we can generate a SSL certificate. We will use Amazon RDS for the database. For the auto-scaling purpose, there's a concept available called horizontal pod autoscaler that we can leverage in Kubernetes side. For monitoring, right, we'll go with the Prometheus and Grafana. That will make sure our services are always up and running in the monitoring tab. So you can even explain the same architecture. Okay. So this will be good for you. Okay. So this is pretty much about the project 17, guys. Yes, probably I'll come and meet you by next project. In the meantime, right, I'm starting a new batch for AWS and DevOps. Almost 20, 25 plus service AWS services I'm going to cover, and important DevOps tools like Python, Boto3, Lambda, CloudFormation, Terraform, Ansible, Docker, Kubernetes, Jenkins, GitHub. All those the important DevOps tools are being covered in that session. It's almost like a 2.5 month of course. It is either you or your friends or your colleague, anybody wanted to looking for the AWS and DevOps course, feel free to real-time project-based training. I'll be the trainer. Feel free to reach out to me. You all know my number where in the every week I'm sharing the meeting link, right? Same thing, you can give me a call back or send me details, so I'll add you in my training group. Okay, that's 2.5 month of course exclusively for 20-25 plus AWS services and 10 plus DevOps tools. Okay, either you or your family members or your friends or your colleague, anybody looking to start learn from the scratch. If people are new to AWS DevOps, starting from the scratch, yes, make use of that batch, which is starting from the next weekend onwards. More than that, right? People, anybody coming from this community group, you will get the flat 5,000 as a discount. Okay, 25,000 is the course fee. You can pay 20,000 in installment. Okay, so yep, that is the background. With that, right, I'm stopping the meeting link. If you have any doubt, I can answer. Otherwise, we can call it as a day.
So, Hari, are you going to share these details about the project, the link to the document that you've shown?
Yes, I'll be recording this. I'll edit it. I'll put it in the YouTube channel. In the YouTube channel description, I'll share the link in the group once it's ready. in the description, right, you will see the steps and document data, everything. Bye.
Okay. Okay. Sure. Thank you.
Cool.
Hello, sir.
Yeah.
Yes, sir. Can you just create one project that is using Jenkins in AWS?
Yeah, which is coming. Maybe it will be like 24th or 25th project actually. Which
Yeah,
is
thank you, sir.
yeah.
Today's project is fantastic, and it will be also very great if you add ingress here.
Yeah, correct. As I mentioned, yeah. If you have a more application we're gonna deploy, Ingress is the right approach. Great. Thank you guys. Take care all. Bye bye.